Okay, so usually the way convolution of discrete time signal is performed is that you take one signal and you reverse it or fold it and shift it through the other signal. This way of performing convolution is actually pretty time consuming. For discrete time signal, you can actually perform convolution much more readily and easier way. So what you have to do is that, look, we have two signals here, x1 and x2. So one is 2578, x2 is 163, and the time index for x1 starts at 5. Time index for x2 starts at 1. Okay, so what you do is that you take the first element of x1 and then multiply it with all other elements of x2. So 2 multiplied by 1, so 2 multiplied by 1, 2 multiplied by 6, then 2 into 3. Okay, then do the same thing for the second element of x1, 5. So multiply 5 by 1, so 5 into 1, then 5 into 6, 5 into 6, then 5 into 3. With the way I have written it now, I have written it one row later and I'm adding it with the previous column, right? So you do the same thing for 7. So 7 multiplied by 1, 7 multiplied by 1, then 7 multiplied by 6, then 7 multiplied by 3. Okay, so you're getting what I'm doing here. I'm actually multiplying every element of x1 with every element of x2, but writing it in a special way. Okay, and the last element of x1, 8. So we're doing the same thing, 8 multiplied by 1, then 6, then 3. Okay, so 8 by 6, 8 by 3. We've reached the last element of x1, so our job here is done. So you perform the summations. This is 2, this is 12 plus 5, 7, 17, this is 6 plus 30 plus 7, so 43. Next one is 65, next one is that's 69, and this is 24. So this will be, if we give y the name of result of convolutions, convolution of x1 and x2, then this will be, okay, notice here that this is the zeroth index of x1, this is negative 1th index, and this is the zeroth index of x2, because negative 1 plus 0 is negative 1, right? So this will be our y of negative 1. This will be our y of negative 1. So this will be our y of 0, then y of 1, and this will be our y of 2, this will be y of 3, and this is our y of 4. So that's it. Our convolution is done. The result of convolution is that y is 2, 17, 43, 65, 69, and 24. Our time index starts here, 17. We can indicate it by this arrow. So that's how we can perform convolution for discrete time signal. Even it's just simple multiplication and addition, even a second grader can do it. Let's show another example to show that how fast you can actually perform it. So we have x1 and x2 here. So what you do is you take negative 2 and multiply it with all elements of x2. So negative 2 times 1 is negative 2, negative 2 times 3 is negative 6, negative 2 times 0 is 0. And we take the second element of x2, 0, and multiply it with all other elements of x2. That's what we get. We take the third element of x1, multiply it with all other elements, 5 into 1, 5 into 3, 5 into 0. Take the last element of x1, so 8 into 1, 8 into 3, 8 into 0. If it is the last element of x1, your work is done. You perform this summation. This is negative 2, negative 6, 5, this is 23, this is 24, this is 0. So result of our convolution is that x1 convolution x2 is negative 2, negative 6, 5, 23, 24, 0. And where will our time index starts? See, these are 0th index, this is negative 1, this is negative 2th index, these are 0th index, this is negative 1th index. So what we have to notice is what is the index of the first element of x1 and x2. So this is negative 2, negative 3. So the index of the first element of x1 convolution x2 will be negative 1 minus negative 2 minus negative 1, the summation of these two. Okay, so this is our, so this is a y, this is actually our y of negative 3. because -2 minus -1 is -3. This is our y of -2. This is y of -1. This is y of 0, and so on. So we can just use one arrow to indicate that this 23 is our 0th index. So these are 0th index. That's it. That's the result of convolution.